In this lab, management wants us to create an IPsec site-to-site VPN. Specifically, management wants us to create an IPsec site-to-site VPN tunnel between router 1 and router 3. IPsec, or IPsec, stands for Internet Protocol Security. An IPsec tunnel lets you create a private, secure connection between two or more full office network locations over the public internet. It encrypts data for privacy. Why use an IPsec tunnel? IPsec tunnels allow secure communication between offices across the unsafe public internet. Encryption protects data from being accessed by others outside the tunnel. Remote offices can connect safely to the main office network. Devices at different sites can communicate privately through the tunnel. How does it work? A virtual tunnel is formed, encrypting packets between two endpoints. Data enters the tunnel and is encrypted before leaving the source site. Packets travel encrypted over the internet to the other endpoint. The receiving endpoint decrypts the data, verifying it came from the trusted site. This creates a secure virtual private pathway between remote offices over the public internet. The main steps to establish an IPsec VPN tunnel are: key exchange. The devices share encryption keys to set up the secure tunnel. Authentication. The devices prove their identities to one another. Tunnel establishment. The encrypted tunnel is created using the encryption keys. Tunnel maintenance. Traffic flows through the tunnel securely. Tunnel termination. The tunnel ends when no longer needed. Site-to-site VPNs connect full office networks. Remote access VPNs, on the other hand, are a different form of VPN that connects individual devices to a network, such as a home to an office. So let's use the command prompt on PC1 to take a look at the current traceroute hops from PC1 to PC2. This will allow us to see how the current PDUs reach the network over at router 2. Right now, we can see that it hits router 1's 192.168.30.1 interface. Then router 3's 192.168.10.1 interface. Then router 2's 192.168.20.2 interface. Before finally reaching PC2 at 192.168.40.2. Once we create the tunnel between R1 and R2, the hops should change and skip R3. So let's start setting up the IPsec tunnel by consoling into router 1. We're going to go through the following steps to set up the IPsec configuration: ISA KMP policy and priority, setting the encryption algorithm, specifying the pre-shared key authentication method for IPsec, defining the pre-shared ISA KMP key and setting the IP interface of the other tunnel end as the peer, creating the IPsec transform set encryption type and authentication type, creating a crypto map for IPsec and ISA KMP, setting the peer for the remote peer crypto map, applying the crypto map to the transform set, specifying the ACL to be used in the crypto map, applying the crypto map to the correct interface on a router, configuring the ACL list, and then permit or deny specific traffic in the ACL. Step 1 is the ISA KMP policy and priority. We have to configure the IKE, or Internet Key Exchange, parameters to establish the VPN tunnel. The command to set up the parameters is crypto ISA KMP policy 1, since this is our first policy. Think of it like setting up the rules for our tunnel and how we talk securely. The command gets us into the configuration mode of our policy. Step 2 is setting the encryption algorithm. We have to decide what kind of code we want to use to keep our messages secret. We need to decide how we're going to encrypt it. Management has told us to choose the AES cipher. Cipher simply meaning a method to disguise or hide our messages. So our next command is encryption AES. Step 3 is to specify the pre-shared key authentication method for IPsec. This is us setting up our secret handshake, pre-sharing the password so each router can know that the messages are coming from one another. This command is authentication pre-share. As part of setting up our secret handshake, we also need to decide the group we want to use. The group is like choosing the complexity of a lock. The larger the group, or lock complexity, the more secure it'll be, but also the more time and resources it will take to open. In this case, management has asked us to use group 2, which is typically a 1024-bit group. Group 2 provides a reasonable level of security without requiring excessive resources to operate. So the command is simply group 2. Step 4 is defining the pre-shared ISA KMP key, our secret handshake code, and stating where the handshake will take place at the other end of the tunnel, which is the IP interface of the other router we want our tunnel to connect to. The command for that is crypto ISA KMP key Cisco @123, which is our secret key, address 192.168.20.2, which is the interface on router 2 the tunnel will end at. Step 5 is creating the IPsec transform set, encryption type, and authentication type. Essentially, we're creating a set of instructions on how to protect the data when it's being sent over the internet. A transform set. The transform set is named Cisco @321, and the data is scrambled or encrypted with AES. Then we also have to make sure we have a unique fingerprint to prove the data came from one of our secret handshake buddies using the secure hash algorithm, or SHA. This SHA fingerprint is combined with a secret key to create a hashed message authentication code, or HMAC. Hence the command is crypto IPsec transform set Cisco @321 ESP-AES ESP-SHA-HMAC. Step 6 is to bring together all these settings into a crypto map, tying them together. Management told us to call the crypto map IPsec-tunnel. And just like ACLs, the map entries have sequence numbers. That way we could add other VPN tunnels to the same crypto map if we wanted to. We'll start with the sequence number 10 for the first map entry, in case we want to add any funnels with a higher priority in the future. We get into the crypto map configuration mode with the command crypto map IPsec-tunnel 10 IPsec-ISA KMP. Once inside the crypto map configuration, we can tackle steps 7, 8, and 9. Step 7 is to set the peer, which, as we stated before, was the other end of the tunnel, which was the interface on router 2 with the IP 192.168.20.2. So the command is set peer 192.168.20.2. Step 8 is to apply the transform set we created, which was Cisco @321. This tells the crypto map to use our data encryption rules we created in the transform set. The command here is set transform-set Cisco @321. Then in step 9, we want to apply an ACL that says, hey, we're only using this crypto map for people on our list. Management told us to call the ACL IPsec_ACL. So the command will be match address IPsec_ACL. Step 10 says we have to apply this crypto map we built to the correct interface. In this case, the interface we want the tunnel to go through is the one leading out to R3, which is interface G000. So we'll put in the command int G000 to get into interface configuration mode. Then we have to put in the command crypto map IPsec-tunnel to apply the crypto map to the interface. Step 11 then says we have to actually create the ACL that the crypto map checks against, which was IPsec_ACL. To create the ACL, we'll use the command IP access-list extended IPsec underscore ACL. Lastly, for step 12, we need to put in the actual rules of the ACL. In this case, we want to permit anything from router 1's office network to get to router 2's office network. So we'll use the command permit IP any. Now save your configuration, save your packet tracer file, and update your notes. I want you to pause here and apply the same settings to router 2. This time using 192.168.10.2, which is router 1's interface, as the peer IP address for the crypto ISA KMP key in step 4 and in the set peer command in step 7. All the other settings should be the same. Okay, so let's take a quick look at all the steps we took in router 2. We have step 1, ISA KMP policy and priority. Step 2, the encryption algorithm. Step 3, the pre-shared key authentication method for IPsec. Step 4, the pre-shared ISA KMP key and the IP interface of the other tunnel end as the peer, which in this case is 192.168.10.2, which is router 1's interface. Step 5, the IPsec transform set encryption type and authentication type. Step 6, a crypto map for IPsec and ISA KMP. Step 7, the peer for the remote peer crypto map, again, which is 192.168.10.2, router 1's interface. Step 8, the crypto mapped to the transform set. Step 9, the ACL to be used in the crypto map. Step 10, the crypto mapped to the correct interface on the router. Step 11, an ACL list. And step 12, the access control entries or ACEs for the ACL. Now, save your configuration. Now try doing a trace route from PC1 to PC2. It may take a bit for the tunnel to get going, so you may have to try more than once. But what you should see is only 3 hops this time. So the first hop is router 1's 192.168.30.1, router 2's 192.168.20.2, and then PC2's 192.168.40.2. Notice how it just tunnels through router 3 now? Awesome. Now let's look at a few quick troubleshooting commands. Show crypto map gives us some basic crypto map information, which includes the peer, the IPsec underscore ACL list, and the interface the crypto map is connected to. The show crypto ISA KMP SA command shows us the destination and source of the tunnel and its status. And the show crypto IPsec SA command shows you the interface the crypto map is attached to. The local address for the tunnel, the peer address for the tunnel, the number of packets that were encrypted, compressed, decompressed, or failed, the transform set settings, and the status of the tunnel. Great job creating your first site-to-site VPN. Save your packet tracer file and then update your notes. Then create your narrative. After that, share the Google Drive folder you have for this lab with anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.